EM mapping stands for electromagnetic mapping. Commonly in Australia we use EM38, which is a soil surveying technology. EM just sends signals into the soil depending on the soil type. It ranges from 1 metre down to 1.5 metres. It's measuring subsoil constraints basically. The big drivers are moisture, texture and salinity. Secondary drivers are sodicity and boron. EM originally was not made for doing surveys, but through the combination of adding a GPS and a computer, we can start collecting data and creating maps which are exactly like your yield maps off your header. So by adding a GPS to the header, we're taking the yield monitor and creating a map with it. Same principle with the EM. You take a piece of information and spatially record it. EM38 correlates very well with yield, particularly in dry years, and particularly in your mallee environments of a dune swale system. There's a range of things farmers can do with EM38 depending on what the ground truthing returns to them. Some of the easiest stuff is soil amelioration, so an EM map picks up sodicity and that farmer can respond straight away with a gypsum application and feel confident they're putting the gypsum where it's required. More detailed stuff we're finding is because EM correlates with soil profiles, particularly in the low rainfall environments, farmers are creating long-term management zones that they use for fertilising their crops. So they're aiming to fertilise where they've got potentially the most plant available water and aiming to reduce fertiliser and seed, reduce inputs overall where the EM's highest, where it's most likely that in an average or below year the yield is going to drop away. EM38 has been identified to create these management zones where farmers can have these long-term set zones and can fertilise accordingly. This not only reduces their risk by taking fertiliser off the heavy soils and putting it on the light soils, but it increases their returns. In other areas where you've got a good duplex soil, sand over clay, there's been some really good work showing that EM can be used to map depth to clay, and then this can be used with delving to always bring up consistent levels of clay or identify areas where the clay is too deep for delving. EM has been shown in certain situations to pick out differences between red and black soils in the high rainfall zones, and has been used for, and this leads to differences in pH. So this has led to liming being more targeted, and so farmers might be still putting on the same amount of lime, but they're targeting to where it's going to get the bang for their buck. Probably the best way to describe precision ag is a methodology. It's not a way of actually solving all the world's problems, but it's a way of identifying them and going through the process where you try new things, different treatments on different soil types, and gradually build up your knowledge where you can start identifying zones where you'll get a yield response to a particular practice. EM is exactly like all the other PA technologies. It's best off for farmers to start with a nursery approach, so do a small area, whether it's 1, 2 paddocks, to identify a new technology and how it applies to them. You generally don't need too many skills to utilise the data. Like a lot of maps, farmers can identify what's going on when they first see the map without any follow-up, but once all the soil testing is combined, all contractors should take soil tests when they take an EM survey. Once that's combined with the farmer's own historic knowledge and the agronomist's agronomic knowledge, that's when the full package comes together and you generally start to kick the goals that you're looking for from variable rate.